Hi everyone. Today I'm going to show you how to solve algebraically for x in a circular functions equation. Now have in mind, circular functions, we're talking about sine, cos and tan. So this is why they're a little bit more challenging. Now with this particular question that I'm going to show you, which is solve for 2 sine x over 2 equals -1 for the domain of 2 pi to 4 pi inclusive. I have not been asked to graph it or anything like that. It's purely algebraic solving, okay? So let's work through it. So the first thing that you want to do is rearrange your equation so that you don't have anything additional around your left-hand side. So where I've got 2 sine x on 2, I want to isolate it so that it's just the sine and x over 2 on the left side. So to do that, if you look, we've got a 2 multiplied by the sine. So what I'm going to do, I'm going to put that onto the other side, and to do that we just use what we know about opposite operations. So I'm dividing both sides by 2. So the first step in writing this out is sine x on 2 equals -1 on 2. Now this is where looking at your knowing your exact values comes in. So think about this. What is, when we're talking about sine x, what is our base angle or reference angle, you may know it as, for 1 on 2? Okay, so don't worry about the negative just for this moment. So if you think about that, you might memorize them, you might draw up those triangles, it's up to you. But we do know that the first thing as the base angle, if you've memorized them, you should know that that is pi on 6. Okay, now this is where I go to my unit circle. Okay, so on the side I'm just going to draw up a really quick sketch of that. Okay, so first of all, I need to work out which quadrants is sine negative. The reason that we're trying to find where sine is negative is because if we look at the right hand side, we're dealing with sine x on 2 is equal to -1/2. So we've already found the base angle, and now we're identifying the quadrants. So let's have a look at that. If we go with our acronym, which is CAST, we know that sine, based on this, sine is negative in this quadrant and this quadrant. Okay, now I'm going to draw in where the pi on 6 exists in this unit circle so that you can get a visual idea of what we're working with. Now if I was going around from 0, so I'm starting here, I know that this is pi, this part here. So that means there's 6 pi on 6s that go in that half circle, that fit within that half circle. So I'm just going to quickly sketch them out for you so that you can understand what's going on, because you know, sometimes it's really helpful, and this will help you with other problems if it's just say you were dealing with positive 1 on 2 in this particular context. So we've got our different sections here, all right, and I need to work out what are my values of the pi on 6 in the negative quadrants for sine. So because I'm dealing with the 2 lower ones, and I always start at my horizontal value and then move from that. So in this quadrant, I start there where pi is. Now, have in mind that because we're dealing in pi on 6s, I like to write that as 6 pi on 6, okay? And that's mainly because a lot of people can make mistakes with the fractions. So let's write it as 6 pi on 6, and then literally all you're doing is adding to the numerator as we move around. So the next part, if I'm going from here 1 up, that means this one is 7 pi on 6. So that is the first value that I'm working with. Now, because it's also in this quadrant, I need to start here at 2 pi and I'm moving around. Okay, I'm going from 2 pi and I'm going 1 before that. So again, if we think about 2 pi in terms of being that same value, but dealing with a denominator that's 6, we're going to change this to, we're going to multiply the bottom by 6, multiply the top. So I'm dealing with 12 pi on 6. That means that's 11 pi on 6. Now, this can also be a really easy way to do it if you have a really large domain. It can make it easier if you're just dealing with the same denominator all the way around. So that can be a good trick as well. Okay, so the next part. We have got our 2 values, but remember, and this is what makes this question a little bit different from maybe ones you've done, we've got x on 2. All right, so we are not just dealing with x equaling these values, we are dealing with x on 2 equals these values. So x on 2 is equal to, now remember we got our first value here and our second value there. Now notice that I'm solving it from 0 to 2 pi, and that's because every time we move around that just repeats. So as soon as we know those first 2 values, we can work with that and then add on the period if we need to, so that we get all the values that are in the domain. So my 2 values are 7 pi on 6 and 11 pi on 6. All right. At this point, because I want to get x on its own, because I'm solving for x, I need to multiply everything by 2. So I'm dealing with x equals 14 pi on 6 and 22 pi on 6. Now, those simplify to 7 pi on 3, because I divide the top and the bottom by 2. And then the other one simplifies to 11 pi on 3. Now, this is where we need to check the domain. 2 pi, 4 pi. So that's our starting value, 2 pi, and can include that value, and then goes up to 4 pi. So this is where we need to check it, because if these 2 values do not fit into this domain, that's where I need to use the period of this particular equation to then work out what those later values will be. So let's deal with the same denominators. So that's the same as 6 pi on 3 and 12 pi on 3. Now, what do you know? These 2 fit within this domain then, because 7 pi on 3 is just that little bit greater than 6 pi on 3, and 11 pi on 3 is that little bit less than 12 pi on 3. And therefore, on both ends, they fit into that domain. Now, imagine if I was asked to do, if my domain was extended, okay, or I had a larger domain. In that case, what I would need to do is calculate the period, which for sine graphs is period equals 2 pi on n, where n is the number that is multiplied by x in those brackets there. So in this case, my n is 1 on 2. So the period is equal to 2 pi divided by 1 on 2, which is equal to 2 pi times 2, which is equal to 4 pi. Okay, so that is the period in this context. So that means that if I needed to, if I had an extended domain, or these values did not fit in the domain, it may mean that I need to go the next cycle around, which in that case, I'm just adding 4 pi onto each of those individual x values to see that they fit. Now, that is how we solve for x in circular functions. Let me quickly recap what we did to break it down into the steps. right, so there's a summary right there. Just remember, it really depends on how you're asked this. You may be asked to draw it up, and therefore in this context where we're solving for x, we're actually solving for x-intercepts, all right? But this is a really helpful way to understand and actually, practice using a lot of the different parts of the circular functions topic. So in this question alone, we are dealing with exact values, we are dealing with the reference angles, we are dealing with domains and how that works, as well as moving around the unit circle to know where certain values exist. So it's a really fantastic one. All right, thanks for watching today. Please subscribe to my channel and I'll see you next time. Bye.